um stream live or uploaded any video. So quite recently, some students have been meeting me, telling me, Mr. Victor, I have issues in 282. Besides, 282 is a physics course offered by university students in 200 level, Nigeria precisely. I don't know which country you are watching us from. So it's a course offered by major physics students and other discipline in the university level. So it's a practical course, 200 level, second semester students. So we are looking at interpreting vernier caliper and micrometer screw gauge. So this micrometer screw gauge in an exams. How do I understand it? Sorry, today I'm not into the practical aspect, but I need to bring the instrument and show you people how to read it. Here we are looking at if it's being given to you in a pictorial form, how to go about it. If it's being given to you in an exam, how do I interpret it very, very fast? So that's what we are doing today. So first of all, you have to know what is vernier caliper. It's vernier caliper. Now, vernier caliper gives a more accurate. It's an instrument that is used to measure objects. But in such cases like this, you will need this thing to measure it. The meter, the vernier caliper. So it gives more accurate result. Remember, I told you earlier that we're not going to the practical aspect, whereby I need to bring in this, bring in that. So I'm just bringing in just only this alone. So in the vernier caliper, I'm very, very fast and quick so that this video can end before 10 minutes will elapse. Okay, the vernier caliper is calibrated. We have the main scale and we have the vernier scale. So in the main scale, it's been calibrated from zero to 5, the main scale, and then it's been calibrated from 0 to 9, and then the vernier scale is also in little decimal point. I don't know, let me just give you a picture from a text. So this is how it looks like. So here is the main scale, so here is the vernier scale. So where it coincides is when we take our readings. So how do I know a particular reading for a thin wire? We use the vernier calipers. As I said earlier, I'm using the one in the text because most probably you see something like this in your exams. So you'll be wondering how the hell do I read it, because it's not a practical exams. It's just what you are going to write the theoretical exams. So I'm going to rush down into how you're going to be seeing it. So it's been diagrammatically, you see something like this, and okay, let's take an example. It's being calculated like this. Here you come here, you see something like 1, 2, 3, 4, 5, 6, 7, 8, 9. Before you see another one here, you see 1 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Another one here, 2. See 1, 2, 3, 4, 5, 6, 7, 8, 9. 3. So they are calibrated in 10 difference. You can see. So now here, what you just seen here is the main scale. Remember I told you that we have the main scale and the vernier scale. So here is called the main scale. The main scale. So for you to get an accurate reading, you have to know the main scale. You also have to know the vernier scale. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Another one 4. Here is the main scale. Perhaps in the next video I will now show you how it is. So let's go back to this guy here. So here is the main scale. What you are seeing is what I'm just reading. If you check carefully, you will see this is a diagram of it, and here is the vernier scale. Okay, so that's what we are going to just read here, and then you're going to see how it's going to be very, very beneficial to you. 2, 3, 4, 5, 6, 7, 8, 9, 10 for the next one. Okay, so the vernier scale diagrammatically, you will see it in this form. Like from the diagram I showed you, you will now see things like lines here. So this line, anyone that coincide here becomes the real measurement. So what we check in the diagram, from here, you put your object here to measure. Now you now tighten this. This is the lock. When you bring it closer, it will close up. When you close up, you take your measurement before this point and where it coincides. These little lines, there are 10 divisions. Anyone that coincides becomes forms the original measurement. So let's dive into it. So in this guy, let's just check this quickly. Here is before 0, right? So here is 0. You continue reading, you continue checking 0.1, 0.2, 0.3, 0.4, 0.5. So it's at 0.5. So what we're going to write is to say main scale reading equal to 0.5. Please note this in centimeters. Now let's go. The Vernier scale. This is the Vernier scale. Now in the Vernier scale, you now check which line coincide. Yeah, you now look carefully. Which one coincide here? You now see this is a raw scale. Okay, this is coinciding. So you say 1, 2, 3, 4, 5, 6. So now say Vernier scale reading is equal to 0.06 centimeter. This is calibrated in the second decimal to the first. Listen, see, so if we now add the two of them, what do we have now? So the total readings for this measurement, whatever we measured here, is 0.56 plus or minus 0.01. This is the zero error. We are trying, assuming there's error on it, so we have to be very, very certain on it. So here becomes your readings for this particular measurement. I believe you could see it. I've told you earlier what you have to do first. Check the reading before this line. This is the Vernier scale. Before the Vernier scale, you have to check. Here is 0 point something to whatever, and here you see 1. Here is from 0 to 9. You see another one. So even though it's somewhere, okay, let's take another example for more clarity. So that we'll understand what we are doing here. Okay, assuming we have another example, this is another last example I'm going to give. So if you don't understand, you can just message me directly, and I will see how I can assist you in any way possible I can. We have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Okay. When you check here carefully, you will see something we are doing here. So check here carefully. Now here again is the Vernier scale. Here is the what? The main scale. All right. So let's check before this line, before the Vernier scale. That's what we'll take our readings. You check here. There is 1 here. So you say 1.1, 1.2, 1.3, 1.4, 1.5. That before the Vernier scale started. 1.5. So we have main scale readings. What do? We write what? 1.5 centimeters. Vernier scale reading. What do we write there? We check which line exactly coincide in the main scale. That constitutes the second to the first. So what we're going to check, you check carefully. Now when you check, sorry for the diagram, I believe in your exam you see it more clearly. This is the line that coincides very, very well, according to my sketch. So we check 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 0.08 centimeter. When you add everything up, we are going to have 1.58 centimeter. So here becomes the reading for this. I'm going to take one last one, and then I think we'll stop here for now. Yes, we'll take the very, very last one, and then we'll then stop here. Let me take another one here. Please, if you anywhere you are not understanding, you can just message me. I will drop my bio down there so that for those students that wish to get more clarity, you can just come and meet me for more clarity, and I will explain it to you. You can search my name as Victor Odo in Facebook, in Instagram, and other social media. You will see me there. I'm everywhere. Everywhere you want to see me, you just see me. Sorry, just a sketch. But the main thing I want to tell you guys, so I can catch up with them. In the next video, I will take my time and use a diagram to to show you clearly the main scale and the vernier scale reading so that you understand it. So they are being calibrated in both centimeters and millimeters. So if you wish to convert it from centimeters to millimeters, you can go ahead and do that. So that's how that's what you can do just here. So okay, all right, let me just cancel this so that we move on to vernier scale reading, because the video is almost, we are almost rounding up the time for the particular video. Okay, let's go to vernier micrometer screw gauge. Please note, for the vernier scale, it's calibrated in both centimeters and millimeters, and the divisions there, we have the main scale and the vernier scale reading on it. And also, when you're taking your readings, before the vernier scale started, you check the readings carefully, and the main scale is to check which one coincide, and it constitutes the second decimal to the first decimal. Why the main scale is always on the first decimal, except before the 1. That's when you see 0.1, 0.2, and so on and so forth. So please note that very, very importantly. Okay, so let's go on to micrometer screw gauge. Micrometer screw gauge here is more precise compared to the vernier calipers. Why do I say it's more precise? In the micrometer screw gauge, you will see some other things. Okay, let's check out the next video for this.